Tech degree from Indian Institute of Technology, Delhi, and PhD degree from DU, New Delhi. Sir is listed among the top 2% of scientists in the world in the study performed in the year 2020 and 2021 by Stanford University. Sir has served in various capacities in teaching for last 35 years. Dr. Verma's teaching and research interests are in the area of image processing, soft computing, AI and machine learning, and many more. He has published patents and more than 80 research papers in the above areas in national and international journals. Now, I am requesting to you, sir, please share your expertise with us.
Thank you. Thank you for your introduction. Unfortunately, today my voice is not in control. So let us, I will try to share the knowledge through the PPT as much as possible. I will speak also.
सर क्या हुआ, गला खराब?
बहुत खराब नहीं, बहुत ज्यादा, बहुत हैवी खराब है। रनिंग नोज है, ड्राई कफ है 2 दिन से।
ओहो, ये विंटर सभी को असर पड़ रहा है।
हो गया। कल डॉक्टर को जिसको दिखाया उसकी दवाई ली, फिर आज फिर डॉक्टर बंसल को से पूछा, पता नहीं क्यों प्रेजेंट नहीं हो रहा। Not responding. मल्टीपल इश्यूज, मेरा लैपटॉप खराब हो गया और मैंने किसी और का लैपटॉप लिया हुआ है और ये रिस्पॉन्ड नहीं कर रहा है।
या तो आपका स्लाइड्स मेल कर दोगे तो कोई कर ही लेंगे।
हाँ, मैं एक काम करता हूँ, स्लाइड मेल कर देता हूँ, ठीक है।
आकांक्षा मेल आईडी इसमें टाइप करो।
पहले मेरा सिस्टम ही रेस्पॉन्ड नहीं कर रहा।
मेल आईडी चैट बॉक्स में टाइप कर लो।
सर आप मुझे भेज दीजिए, मैं
एक सेकंड ट्राई कर रहा हूँ, हो सकता है।
मैंने अपना वो टाइप कर दिया आपको मेल आईडी चैट बॉक्स में।
तो मैं ट्राई करता हूँ दोबारा प्रेजेंट करने की। अच्छा, दिख रहा है?
यस सर फॉग कंप्यूटिंग दिख रहा है सर।
जितना पॉसिबल है स्पीक कर पाऊंगा। Actually, this fog computing, the term was given by the Cisco. And my today's talk is related with the fog computing and the IoT. In fact, IoT is very broad term. We have IoT devices, and they are connected, and we are sending the and receiving sometimes the information through the cloud also. So if you look at this particular diagram, then we have here it is the cloud, and here it's the end devices, your IoT devices, and in between there is a fog. Similarly, there is a concept of this fog computing. As you all know, the dictionary meaning of the fog.
हेलो
हेलो, आवाज आ रही मेरी? हेलो,
आ रही है सर, आ रही है।
यस सर।
you all know the dictionary meaning of the fog, which is in the first bullet point. The same meaning here in computing also. So if I want to summarize the fog computing in one sentence, before the fog there was a cloud computing, and cloud means we are sending the data to the cloud, all data, and then again getting the data from the cloud, and the data is stored in the cloud sometime, and after the processing we are again getting back it. So each and every data was being sent to the cloud. So there is a issue of the bandwidth. Now, instead of sending all the data to the cloud, we can think about doing the computing in the intermediate level, so that the bandwidth and latency problem will be reduced. So that is the idea behind the fog computing. So as third point is there, the fog network remains near to the ground as compared to the cloud. So there is a there is an intermediate computing concept, and this concept is not very old. It is started in 2012. One student from the computer engineering department is doing the Ph.D. under me and Professor Manoj Kumar in the fog computing. This is the one of the possible definition of the fog computing. So, like there is the Internet of Things, then there is another word, cloud of the things. Because Cisco has started this concept of the fog computing. So here, the Cisco was having a vision for the fog computing. I request you please go through these one. Like it's my personal view, IoT, before the IoT, we have the wireless sensor network. So I can say the IoT is the extension of the wireless sensor network. Only thing is, in the wireless sensor network, we are sending the data, receiving the data from the sensor. But in the Internet of Things, we are also processing it. So what is the role of the fog computing in IoT applications? Basically, Internet of Things is nothing but it is an application. It's application. So this is the forecast. And it may be less also, the way in which the sector is moving. We are having devices, one person having more than one devices. So this slides indicates the growth forecast. The Internet of Things, basically, the most important part of the Internet of Things technology will be the connected cars in the future. And there we don't require, we don't need to process the information to send it to the cloud. It, that is at the distance end, very distance end. It takes the time also. And if you are talking about the connected cars, I didn't want the millisecond response time. So in case of the cloud, this for computing, this response time decreases. That is latency rate. So the last point is fog computing can play a very important role to process this data at the user end itself. So why the fog computing came into the picture? Because in today's cloud paradigm was not built to handle huge volume of the data produced by growing IoT devices. Although this is this by the year 2020, it has already been passed. So this is the statics. The same is being represented. It's described in this slide. So as I told you, the sending and receiving, sorry, sending and receiving data from the cloud is a time-consuming process. So the fog computing can process and store this data near to the end user. architecture. So as I told you in the initial slide, so you have a IoT devices, then some of the process may be done at the fork level, and some of the process are required at the cloud level, depending on the applications. Like if I take the Google Map example, it shows the almost correct time, and it uses the two datas. One is the previous data, that means uh, process data taken from the cloud, and another is a present data, that is a process at the fog level. So these two types of computing being happen simultaneously in case of the this Google Maps. This is one of the example. So this is the detailed architecture. You can see from the edge devices, you can send directly information to the cloud also. And cloud is nothing but it is remotely place high processing units. Like in India also, we are putting at the Hyderabad. Google now putting uh, the center in the Hyderabad or in Chennai, I'm not sure. So that is called as a cloud. Distance. So you can see lower one is the end user is the edge layer. Then it is the fog layer, in which we have the switches, routers. These are the fog nodes. These are the fog nodes. So we are processing here itself and receiving the information back. And if it is required, sending it to the cloud and getting back. So this diagram, this architecture, clear about the concept of the fog computing, including cloud and your IoT devices. All end users are the IoT devices. So how fog computing works, you can go through this slide. So this slide will clear the idea how fog computing works. As I told you, the fog node sends data to the cloud server also in case if high level of processing is required. So these are the example of the fog nodes. The right side is the fog concept, and left side is the the concept of the cloud. So the diagram is now explained in this PPT. This is nodes are Cisco IO, Extend, Cloudlet, which is so on. So, what is the responsibility of the fog layers? Again, it's a three-type architecture. We have the IoT devices. So, fog node will be doing monitoring also, computing also, temporary storage also, networking also. So why people think about using the fog computing? So see this data center, that the center is nothing but it's a cloud. And here we are doing the edge computing devices. And these are the application, connected cars, smart grid. This diagram indicates how the processing is being done. This model was given by Cisco in 2014. So if you look at this latency, here we have this edge computing very low. Then it is if we are doing at the cloud level, then medium, and if it is done at the fog level, cloud level, sorry, if it is done at the fog level, then it is medium. So one of the important criteria is the bandwidth requirement. So it reduces the bandwidth also. So this slide indicates how the fog computing overcomes the cloud, some of the cloud problems. Although there is no substitute of the cloud computing, fog cannot replace the cloud. So as I told you the last point here in this slide, the role of the fog computing comes in, which can produce the real-time data processing, it can process the real-time data and reduce the need of high bandwidth. So some of these points why we use the fog computing are included in this PPT, this slide. So this is one of the example. You have a Pokemon game example. And in this, in fact, any online game, you require the response immediately. So from this diagram, you can think about how much time it takes to get the information back or to play the Pokemon games. So if you are in the North America, then it requires very less time because infrastructure is situated in the North America. Cloud infrastructure is situated in the North America. So this diagram indicates the time delay. That is latency is being increased. In fact, this has been described. This diagram or this graphs has been described in this table. The same is described in this slide. So this fourth point is the server was located in the data center near the east of America. And to play the game, the user from Asia had to wait 26 times longer than those close to the server. So this is just one example how serious the quality of service of latency. The final point in this slide is fog computing help in getting quality of service for online gaming due to the low latency. Characterization of the fog computing. So those earlier PPTs detail are summarized, as I told you earlier, low latency because data is processed close to the user, graphically large scale sensor network, transferring metadata to the cloud, a real-time application, and obviously it is robust. So, so low latency is because the fog paradigm work near the edge network, so its latency time is very small as compared to the cloud. So many applications such as traffic control, telemedicine, industrial IoT needs low latency because I need the information immediately. Automatic traffic control, I cannot wait for processing the data. So fog is a distributed deployment. It helps in many applications for moving vehicle. So there was a problem in the cloud, so that some of the problem has been is being taken in the fog environment, fog computing. The transferring metadata to the cloud. Fog nodes send only small amount of the metadata to the cloud without fog, all data were being sent to the cloud. So it helps in better bandwidth utilization. So obviously those applications need not to process in the real time are sent to the cloud by the fog, not for processing. So this fog works like an intelligent agent between edge device and cloud. So it is helpful in real-time application. Since it is a distributed network, so its repeatedness, so failure of the one fog does not impact on the other. That is also important advantage of this fog computing. If one fog node is not working, the another will not be impacted. So there is an advantage and disadvantage of the fog computing, and with respect to the cloud. This advantage and disadvantage is with respect to the cloud computing. So from the earlier side, you got this idea. So third point is important point. We can install the fog node in movie vehicle also. Point bullet point number 5 is also important for security point of view. And another important advantage is the new fog application can easily be developed according to the need of user. And we can install the fog node in the remote areas. So there is a disadvantage also. But this disadvantage will be overcome by can be overcome. So second point right now is the cost and availability of the fog equipment is a concern. Intel people are also working. Intel is also working in the fog computing nowadays. These are the disadvantages. So, because there are three, at the edge we have the IoT devices, then there is a fog computing and then the cloud computing. So, it's edge versus fog versus cloud. Some information is being repeated to have the more idea. So The first point is very important. The advantage, in fact, the disadvantage of the cloud are overcome by the fog computing. So, as I told you earlier, we cannot replace the cloud computing by the fog computing. So, this slide, you can see the important comparison. In fact, for example, storage capacity, I don't require the high storage capacity in case of the fog computing. So, storage capacity low. Another important point is the maintenance. Generally required no human involvement, as it is required highly technical experts in case of the cloud. But mobility management, because it is not easy here in the fog, because we are putting the devices even in dynamic mode also. So the small company can also operate the fog, work in the fog environment. But in case of the cloud, we require the large infrastructure. So it is operated by the large company only. So it will give you the idea about the IoT devices computing. That is edge computing. I'm doing the, for example, doing at the my phone level some computing I'm doing. Edge computing, the data is processed right on the device or gateways devices close to the sensors. So this slide gives the idea what the difference between the edge computing and fog computing. What is the future of the IoT with fog computing? So one of the greatest advantage of the fog computing, it reduces the bandwidth requirement. You cannot say there is better security, but it has been proposed by some people working in the cloud. These are the real world examples. IoT and edge collaboration. self-driving cars, smart thermostats, smart home, virtual and augmented reality, smart cities. So this edge performs the accelerated devices for IoT application. So these are some of the example for computing applications. And it is nothing but we are having the IoT devices. Like in autopilot car, you have a number of IoT devices. Smart grid, connected vehicle, healthcare 4.0. So this slide describes some points related with the autopilot cars. So third point is important point. Why the cloud concept, so this folk concept playing the role. The sales data need to process in real time, which is not at all possible by communicating this data with cloud. In real time means I want the process data immediately without delay. Now the smart grid are being smart now. Similarly, in the healthcare, how it is used. Although such type of operation was being done earlier also, but the name is given lately, like this for third point. This done by the IT. Blood pressure sensors can send the patient data to any fog unit, which can process it very fast and can report to a nearby hospital in case of the emergency. And in surgery also, because if it is being done from the remote, the doctor is at the remote guiding the other doctor, then we require data at very fast rate. You can do the real-time video analysis also. Camera because this video has the memory requirement in the video is large. Therefore, the bandwidth requirement increases in case of the video if you are sending to the cloud. So this is, as I told you earlier, example of the connected car or smart car. can put the fog nodes in the vehicle itself. So fog node for the connected vehicles. So the last point in this slide, the fog node on vehicle help in processing this data in real time, which later can also be shared with manufacturer for future improvement in the cars. So this is some of the related work. So in fact, this is very new area. One who was thinking to work in the cloud computing now can think about work in the fog computing environment. So what will be the future of the fog computing? This compounded annual growth rate of control and account general, according to them, will be 55.6%. The market will grow. So there is a huge market. So these are some of the references. So thank you very much. Unfortunately, I cannot speak too much.
Hello, sir.
Hello.
Sir, I am Mallikarjun BC from SIT Tumkur. Sir, I have a question, sir. It's a really interesting concept to collect the data from wireless sensor network. It may be applicable to agriculture or it may be applicable to smart lightning system, whatever it is. When we collect the data, sir, usually in our project works with the students or with ourselves, do the storage in cloud usually, either TeamSpeak or Firebase or Google Cloud, whatever it might be. Usually we do that. So nowadays the fog computing playing a very important role, as I have observed, and your PPT clearly tells us the fog computation advantage. Now, how exactly we can?
One thing I want to clear you. I am not an expert of the fog computing, first of all. No?
Yes, sir. Now my simple question is, sir, how to go ahead with fog computing initially, sir, in initial stages? How exactly we can start with working on it?
So, we have around 40-page papers. It
Okay,
is
sir.
under the second review stage. Uh, mm, it's a review paper.
Okay, sir.
Almost all it is 40-page paper. So I can share that once it is published. So the idea is given. It is in the second stage of the review, and
Okay.
99% it is going to be accepted within a 1 month period. So we
Okay,
all
sir.
given the idea about how to use them, and what are the problems can be taken using for. There are 6-7 areas in which this fog computing can be used.
Okay, sir. Okay.
I
So,
can just share the, because it has not been published till now, so, and it is in the review stage. Definitely, once it is published, you can contact me. I will share the all new research ideas are given. And since
sir,
it is 40-page paper and in good journal.
okay, sir. Could you please share your email ID, sir, for us so that we can be in
Yeah,
touch with you in future?
just a minute. And I have already sent the PPT to the madam. She will share to all participant. मैडम पीपीटी आप शेयर कर देना ये वाली सबको.
यस सर, ओके सर, ठीक है जी.
जो मैंने भेजी ना आपको मेल किया
राइट
ना,
राइट.
उसको आप दे देना, शेयर कर देना सबको, पूरे पार्टिसिपेंट को. इनफैक्ट सर हर सेशन की पीपीटी तो पार्टिसिपेंट के पास जाना ही चाहिए.
यस सर, यस सर, वी विल शेयर द रिकॉर्डिंग्स आल्सो.
अच्छा ठीक है.
Right. Are there any other questions,
Thank you,
participants?
sir. Sir, I have one more question. What are all the different fog computing simulation software, sir? Like,
There are very less, in fact, na only Cisco. Uh, mm, I don't have too much idea the softwares.
okay, sir. So, what Cisco you have specified, it is basically licensed one, right, sir?
Yeah.
The Cisco one which you have mentioned, which is licensed software, or I mean, the simulation software.
I think it is a licensed software, but I'm not sure about it. But open source software is available for this one or not, I'm not sure. But
Okay,
see, this is not a kind of, we can say, the software. No, we are software we are using. We are having open source software. Only thing, running them on the cloud. Now, instead of running them in the cloud, you can run them in the fog environment. So,
Okay,
software,
sir.
any software can be, which we are developing, can be used in the cloud fog environment also, which is being in the cloud. Only thing is the process data will take the less time.
Okay, sir. Thank you, sir. Thank you.
Any other questions? Okay, I think there is no questions. So, Akanksha, are you there, sir? Should we close it now?
Yes, ma'am.
Okay.
We would like to thank you, our expert O.P. Verma sir, who honored this FDP and enlightening all of us with his expertise. We learned various important aspects like fog computing, architecture of fog computing, role of fog computing in IoT applications, disadvantages and advantages of fog computing with respect to AI. So all these topics are very important and very informative. Sir, we really learned a lot from your expertise. Thank you so much, sir, for this informative lecture. Thank you, sir.
Thank you very much. Special thank to the Professor Indu for giving me the opportunity. In fact, this is